Okay, this is the bonus from the test, and I want to show you a couple of ways you could have approached this problem. First of all, it says Mrs. Smith spends exactly $3 a day on apples. When the price of an apple rose by 10 cents, she had to buy one less apple per day to keep to her $3 amount. How much did an apple cost before the price increase? One way you can do this problem is by trial and error. You can imagine how many apples she might have bought and then try a few possibilities and see how they work out for you. You could say, well, $3, I'm guessing she didn't get more than 10 apples for that. So I'm going to try 10 apples, and I'm choosing an amount of apples that divides evenly into 300 cents or $3. 10 goes into 300 30 times. So if she buys 10 apples, that means they are 30 cents a piece. It says when the price of an apple rose by 10 cents, she had to buy one less apple to spend $3, right? So the apples rose to 40 cents each. Price rose to 40 cents each. And it says she's going to buy one less apple. Well, 40 cents times 9 apples does not equal $3. So forget about it. That doesn't work. All right. You might say, all right, well, maybe she bought 9 apples. Well, 9 doesn't divide evenly into 300. She bought 8 apples. 8 doesn't divide evenly into $3. 7 doesn't divide evenly into it either. So you might get down to 6 apples. 6 apples. And if you divide 6 into $3, that would mean that each apple was 50 cents. The price rises 10 cents, so price rose up to now 60 cents. 60 does divide evenly into $3. That means if you bought 5 apples now at the 60-cent price, that would be $3. So she is buying one less apple, $5, 5 apples at 60 cents each is $3. So this one worked out. Just trial and error probably would not have taken all that long to figure it out if you made some educated guesses and thought about it. So if she bought 6 apples, they were 50 cents each to add up to $3. The price rose from 50 cents up to 60 cents. And now to pay $3, she has to buy 5 apples, which is one less than 6 apples. So that fulfills all the conditions of the problem. So that is the answer. Apples originally cost 50 cents. Now, what if you wanted to do it using algebra instead of trial and error? All right. So we're going to look at the two different situations before the price went up and after the price went up. So before the price went up, we'll say that the price of an apple was P. P is the price of one apple. And I'm going to keep all my prices in cents because I don't want a bunch of decimals in my problem. So P is the price of an apple in the beginning, and the number of apples she bought, that's another thing we don't know. So we'll call that just A for apples, the number of apples she bought. All right. And so that $3 is P times A, the price of an apple times how many apples she bought. That multiplied together to give me $3 because that's how much she spent on these A apples. So price of an apple times the number of apples she bought was $3 or 300 cents. After the price went up, the new price is 10 cents more. So it's not P anymore. It's P plus 10 is the price of one apple. And the number of apples she buys now is one less than it used to be. So that's the number of apples she's buying now. And it's still coming out to be $3 when you multiply the two things together. The price of an apple times the number of apples she buys is still going to be $3. She's sticking to her $3 price. So we have two equations and two unknowns, so we know that we can solve for A and P. So I'm going to use the distributive property over here on the right and multiply this out. So I've got PA minus P plus 10A minus 10 equals 300. And now I can, so what I want to do here is I can use this equation over here, because this is still true. It is still true that P times A is 300. I can use that to substitute into this equation I just wrote for PA. So for PA right here, I'm going to substitute 300 minus P plus 10A. And I'm going to move the 10 right here over to the right side of the equation, so it'll be 310. Now you notice I still have two unknowns in one equation. I can't solve that. So I'm going to go back to this first equation and use it again. This time I'm going to solve for P in this first equation by dividing both sides by A. So P is equal to 300 divided by A. So now I can put this in to this equation for P. So 300 minus 300 divided by A plus 10A is equal to 310. And so now I can subtract 300 on both sides, and I'll have negative 300 over A plus 10A is equal to 10. And now I'm going to have to multiply this whole thing through by A, because I've got an A in my denominator, and I don't want that. So I'm going to multiply everything through by A, and I'll have negative 300 plus 10A squared is equal to 10A. Now what you have is a quadratic equation. Now, I believe you did learn how to factor in Algebra 1, so you actually do know how to solve this kind of equation, even though it's not very familiar to you. So the way we do that is we get everything on the one side and have 0 on the other side of the equation. So I'm going to subtract 10A on both sides of this equation, and I'm going to rearrange everything on the left side so that I have 10A squared minus 10A minus 300 equals 0. And the last thing I'm going to do before I solve this is I'm going to divide everything by 10. 10A squared divided by 10 is A squared. And then 10A divided by 10 is A. And 300 divided by 10 is 30. And that's supposed to equal 0. Now, if you recall, you learned how to factor in Algebra 1. Maybe you didn't learn it all that well yet. But what you're going to do is think of two numbers that will multiply together to give you 30, negative 30, and that will add up to negative 1. And those two numbers would be 5 and 6. And since you want a negative 1A, you're going to make the 6 negative and the 5 positive. And when you have two things that multiply together to give you 0, you know that one of them has to be 0. So either A plus 5 is 0, or A minus 6 is 0, which means that A is negative 5, which would be impossible. An apple is not a negative thing, it's a positive thing. So this tells me that A is 6 apples. So that's how many apples she originally bought, was 6. And if you remember when we did this by trial and error, we knew that she bought 6 apples to begin with and then had to knock it back to 5 when the price went up. So if she bought 6 apples to begin with and it was $3, then each apple had to cost 50 cents in the beginning. So that's a tricky problem, and that's why I gave it to you as a bonus. And I'm going to give you problems like that for bonuses because you really should learn to think and problem solve and try strategies and try this and try that. Because when you get good at that, you are very powerful. You're able to do things that maybe some other people are afraid to do. You're willing to try when you start to succeed at these kinds of things. You're willing to realize, well, hey, maybe I can really actually think myself through this and I don't need somebody to tell me how to do it. So that's what the bonus problems are for, to help you learn to think and to help you learn to push yourself a little bit to not just always know exactly how to do the problem. So those are two ways to do the bonus. I'm sure some of you had other ways to do it, uh, and if you can explain that to the class, then that'd be great too.